Okay, now we're doing section 6.3. The date on the top of your paper, 3/26/14. You'll like this one, it's much easier. Multiplying expressions. Or actually multiplying rational expressions. Now, to review multiplying fractions. Is really a pretty simple deal. A over B times C over D, which we've talked about this before. You multiply the top, it becomes one fraction of A times C over, and you multiply the bottom, B times D. Sometimes there are ways you can reduce before you multiply, or you can reduce after. It doesn't make a difference. So, with multiplying expressions, you could have something like this: x squared over y squared times a squared over b squared. I've made this one pretty easy. We're going to, nothing up here will reduce with anything down here, so you multiply the top. X squared times a squared, well, you always put it in alphabetical order, so it'd be a squared x squared over, alphabetical order here would be b squared y squared. Does the alphabetical order really matter? It's just kind of to give us a baseline so everybody's answers will look the same. If you put x squared a squared over y squared b squared, is it really any different? No. You'll get the same answer if you plug numbers in, but to understand the language of algebra, they usually want you to write it from left to right in alphabetical order when you have a bunch of variables multiplied together like that. That's all you got. However, guess what? They're not all going to be that easy. Sometimes I'm going to want you to factor them. So, once again, I'd like every one of you to write this down. Now, I'm going to sit it here for a second. Ms. Kinney can press pause. You guys write this down for another time on this set of notes. The reason being, the more I have you write it down, the more likely you are to remember it. Okay, so pause and write this down. Now, after writing that down, let's go do some problems here. What do you say? Let's find my examples over here. Excuse me, I'm not finding my examples. Let's do something like this. Let's go a minus b over x to the third plus y to the third times x plus y over a squared minus b squared. Now, whenever you have these, before you go any further, before you multiply and get this whole thing and start multiplying all this junk together, make life easier on yourself. See if there's a way to reduce. First of all, here, a minus b, probably can't reduce that. Or probably can't factor that in any way, I'm sorry. So there's nothing to reduce now, because you have to have parentheses that are exactly the same. X to the third, b to the third, does it look like something here? Does it not look like number 3? It does, doesn't it? So with that in mind, let's factor that. Your a minus b, we've already decided that would stay the same. And remember, put your dot, because now we added over the last 2 days, now we're multiplying. This would factor to x plus y times the quantity. Well, we're focusing right here now. Basically, our A is x and our B is y. So, times the quantity, let's see, this would be x squared minus xy plus y squared. All of that times, now that I've factored that, let's try to factor this over here.
Brian Dunn, please call senior attendance. Brian Dunn, please call senior attendance.
If you look up here on top, there's nothing more to do here. But on bottom, that is the difference of perfect squares. That is just like number 5. So I could factor that into a plus b times a minus b. Now look at this. When I multiply these, is there anything to reduce? If you'll notice, isn't this and this now the exact same thing? Won't they cancel? So instead of having to multiply through and multiply these, you've got a little bit of an easier deal now, don't you? And if you'll look here, how about this and this? Are they the same? Yes, so they can cancel. So now all you're left with on top, we got to understand that's a 1 when it cancels, and this is a 1. So really, when you multiply through here, all you're left with is a 1 on top. All you're left with on bottom is x squared minus xy plus y squared times a plus b. Easy peasy. As far as I'm concerned, that's good enough. Leave it just like that. You don't need to anytime you factor it, I'm not going to make you multiply it back through. We're factoring it to see if it what? It cancels. Another way to look at this problem, if you were confused by how we canceled out before we multiplied, you could just make this into one big fraction. Multiply the top. It would be a minus b times what? X plus y. On the bottom, you would have gotten x plus y times what? X squared minus xy plus y squared times a plus b times a minus b. You see how I just basically combined that all on the bottom there? And now you look, same, 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 same. You're left with a 1 up here and that on the bottom. So you can also do it that way. Pause if you need to. Now, going on to another problem. They're not all going to be that bad. That was one of the harder ones. But we are going to have some like that. Let's go with 2x to the third over y to the second times 5x squared over y. Is there anything on top that will simplify with anything on bottom? Cancel out. There isn't. So multiply the top. Okay, worry about the numbers. 2 times 5 is what? 10. X to the third times x to the second is x to the fifth. Because this is like x times x times x. And this is x times x. So now when you multiply them all together, you're now multiplying 5 x's together. This is 1x and 2 of them, so now you're multiplying y to the what? Third. Let's look at number 9 from your assignment. It's another one of the more complicated ones that require factoring. We've got a to the third minus b to the third over a squared plus b squared A plus B quantity squared over A minus B. Let's look at our list. This one right here is just like number 4. Is it not? So the top here could become, we're right here now, A to the third, or I'm sorry, A minus B, A squared plus AB plus B squared. All of that over. Well, now let's look at this. Is there an A squared plus B squared here anywhere? There isn't, is there? So we'll just write that as A squared plus B squared. All of that times, well, that's already factored. A plus B quantity squared. All of that over A minus B. Now, we have to understand that this and this are very different things. If you were to multiply this out, there'd be a middle term. So you cannot cancel these. That's why I'm doing this problem. When we break down everything we have on top, we basically have A minus B times A squared plus AB plus B squared times A plus B quantity squared. On the bottom, we have A squared plus B squared times A minus B. Now, do we see anything that's the same that can cancel? The A minus B and the A minus B. So these cancels out. These two cancel. So as a result, and what I want you to write as your answer for right now, A squared plus AB plus B squared times A plus B quantity squared over A squared plus B squared. And that's your answer. That's good enough. The reason is, and if you look at this again, this looks a lot like this, doesn't it? So you may think you can factor it into that, but you actually can't, because there has to be 2AB in the middle. It's not 2AB. Once again, next week when I get back, we're going to go over this again, and we're going to go to the next step, and we'll multiply all this back out and see what we're left with. Okay? But this is number 9 on your assignment. Your assignment is numbers 1 through 10, write problems, draw figures, show all steps, and work.